Each year, traffic congestion and related costs create a multi-billion-dollar toll on our economy. Road and bridge construction projects are a major cause of that congestion. And with over 150,000 bridges across the U.S. in need of repair or replacement, this issue is not going away anytime soon. So the need to discover and promote ways to reduce these construction-related traffic delays has never been greater. This is the story of an accelerated bridge replacement project and the innovative, time-saving, and cost-effective techniques used to reduce those delays. Accelerated bridge construction is defined as replacement or new bridge construction that uses design and construction methods to minimize impacts to the traveling public, commercial transportation, and the environment, all while maintaining the highest levels of quality and safety. Although ABC has been used successfully in more than 200 projects in the U.S. and abroad, implementation has been sporadic and usually limited to high-profile or one-of-a-kind projects. Initiated by the Second Strategic Highway Research Program, or SHRP 2, the Cade Creek Bridge replacement was designed as a demonstration project to promote a broader use of ABC.
This project was self-performed by a local contractor. Right on site, he basically leased a piece of the farmland next to the bridge and had his own crews precast all the pieces and lift them into place. And that's exactly how we had designed this bridge.
This demonstration project is really the culmination of a 4-year data collection process. We've looked at results from over 200 accelerated construction projects from around the country and in fact from around the world. And we've taken the best of those details from proven projects around the country and pulled them into one demonstration project. That's the purpose of what we're doing here. We're taking good details, proven details that are liked by bridge owners from around the country, assembling them in one place, and then we can test it all, prove that it works, and then pass these along as standards that can be used elsewhere.
Accelerated bridge construction projects take many forms and use various methods. The Cade Creek Bridge was prefabricated as a set of 30 large components built adjacent to the bridge site. These components, which weighed up to 65 tons each, were then moved into final position and reassembled during the ABC period. This process allowed the contractor to apply his experience building conventional bridges with typical equipment and techniques. This eliminated much of the normal learning curve often associated with innovative projects.
Parts of it are real unique. I'd say 85–90% of it is just another bridge. That's the way we approached it. Yeah, it's in pieces. It's precast. We've done precast before. We'd set precast beams all the time. It was a whole different set of challenges. But as far as building the bridge and the way we decided to do it, building it on site, on false work, was probably the most unique thing that we did. I'd say 85–90% of it is just a bridge. It's like lots of others we've built, but it's in 18 pieces in the superstructure, and then 8 pieces down below. 2 abutments, 2 pier caps, 4 columns, and then the drilled shafts it sits on.
From the very beginning, some of the design decisions that were made, we wanted to make sure that our local contractors were going to be able to build a bridge like this one. So that helped us decide what the superstructure was going to look like and several of the other design decisions. I think that's very important because we don't want to do research that's a one-of. I'm not really interested in looking at something that we're just going to try once. Why would we put money, time, and effort and expertise into that if we're not looking for the long haul with these opportunities?
Contractors, the unknown means a higher bid that you'll probably get. So with SHRP trying to do these demonstration projects, we'll get the information out there of how they work, get some of the kinks out, and give that comfort level to states to move forward.
As the new bridge is built in pieces and then lifted into position, there needs to be a strong glue that binds all these pieces together and provides a seamless structural continuation. For this project, ultra-high performance concrete, or UHPC, was chosen as that key ingredient. UHPC is a reactive powder concrete with approximately 5 times the compressive strength of conventional concrete. For Cade Creek, UHPC was used for all the key joints, including the transverse joints, the first time it has ever been deployed for transverse joints in a bridge. This unique application of UHPC creates a more durable and longer-lasting bridge, more protected from de-icing chemicals and capable of carrying higher capacity loads.
What we're basically doing is creating a bridge that's going to be assembled out of essentially out of Lego pieces that are going to be prefabricated and connected using some high-strength composite materials. Whether it's a high-strength grout material to put column and cap beams together, or whether it's ultra-high-performance concrete to connect the superstructure pieces together. This is one of the first times ultra-high-performance concrete has been used in bridges like this, especially in a rapid construction environment. And it's really a kind of a leap forward in the idea of using UHPC for continuous bridges.
What makes the ultra-high performance concrete ultra-high performance is all the constituent materials, the particles are so finely or carefully graded that they all pack so densely together that you can get this really stiff matrix. And with that dense matrix, then the fibers actually almost act like reinforcing bars on the miniature scale. We built a mock-up of this really critical transverse joint, and we put it through its full loading range. First we went up through service loads, which means the stresses that the traffic will cause on the bridge. We did that. We did fatigue testing where we cycled it back and forth. We pounded it for 1 million cycles all the way up to service level. And then finally we tested the retrofit with the bolts, and then we pushed it as far as it would go to its ultimate level.
The design decisions and the details with this project are very unique. They have done UHPC for the connections between the precast elements before, but this time they are transverse and longitudinal. That's an important element of this. We put a lot of de-icing chemicals on our bridges in the winter. We do not anticipate stopping that. It's a safety issue for us, and so we need to have something that is very strong and impermeable, and the UHPC is giving us on this bridge is giving exactly that.
In keeping with environmental standards and adding to the renewal aspect of the project, materials salvaged from the old bridge were separated and reused, the concrete for fill around the new bridge, and the rebar hauled away and recycled. To best ensure ABC becomes a common solution, standardized methods are needed to further streamline on-site construction, minimize traffic delays, and save money.
Well, that's part of the goal, I think, of the SHRP 2 program is to, one, standardize what they're doing, show contractors through their pilot projects these techniques work, and then show that they can be repeated.
Once you standardize the processes, the price comes way down. Once you learn how to build bridge elements, precast bridge elements, so that they can be moved by standard equipment on a highway project, then again, the cost comes down again. The goal of the SHRP 2 project, the RO4 project, is simply to make accelerated bridge construction an everyday process.
A primary concern when proposing ABC projects is constructability and affordability. Can local contractors do the job with familiar techniques and existing equipment, and for a competitive price?
One of the values of this particular project is that it's not particularly exotic. It's common structural elements, materials, but these are the kind of products, if this technology is implemented a little more broadly, that contractors can be comfortable bidding on this. Agencies will be comfortable designing these kind of projects and looking for, not just wait for the right application to come along, but actually looking for applications where this might be repeated time and again, because that's where you'll get your savings.
Getting contractors more on board, include them early. Include them early in the discussions. We've done a number of ABC bridges in Iowa. We had one of the first of the 3 Highways for Life projects, and that was an accelerated bridge construction project. And we included the contractors early, and we want to make sure that what we're coming up with is constructible and that we're making the best decisions we can for the construction ideas that we have.
The Keg Creek project proves that any contractor used to doing conventional construction could do this type of work. This contractor was able to use his experience building conventional bridges. Didn't have to change a lot of his construction technique. He actually built the bridge as if he was building it exact location. He built it off-site, but he still used the same techniques he did building conventional bridges.
contractors, the construction industry, they almost have to be, I believe they're a little further ahead of us than we are as designers, because they are business people also, and they need to look to the bottom line, what cost and getting things done, and so they're going to be instrumental in kind of pushing the envelope.
In order to assess the bridge's performance, the research team installed strain gauges and other monitoring devices and performed a live load test before the bridge was open to traffic. These same gauges will be used to monitor any changes over time.
In the demonstration bridge, we will be actually instrumenting the same portion of the transverse joint over the piers in much the same way that we have here in the lab, so that we can make comparisons between live load testing that we'll do once it's completed versus what we've done in the lab.
Any worthwhile demonstration project includes important lessons for future study. Although the SHRP 2 Cade Creek Bridge project was a lauded success story, definite areas of improvement were discovered.
One of the reasons for also doing this project for us to test out our concepts, our details, and take the lessons learned and make our design standards for ABC even better.
You know, I think what we learned is that the rebar layout needs to be changed, you know, for more tolerance. Because if you did precast it, the rebar is way too close together, and if you were off just a little bit, you'd never get it erected. You know, the UHPC is, you know, we pretty much knew what to expect. That we used over 8,000 self-tapping or drilling Tapcon screws to hold the plywood up on the bottom of it to keep it from leaking, and used silicone. Tried to make watertight joints, and it seems to be working pretty good so far.
The contractor, I think, learned a lot of things in terms of putting the joints together. I think we as designers learned we need to give them some more tolerances in different places in some of these joints, make the rebar a little bit easier to work around, maybe reduce the number of rebar, or at least reduce the potential number of conflicts with the rebar in these various joints. But those are all easy problems to solve.
Innovative ventures involve risk. The goal of this research and the Cade Creek demonstration project is to use proven construction details gathered from around the world to reduce that risk, so others will consider ABC techniques for their next bridge project.
A lot of people have ideas, but how do you know if they're going to work or not going to work? You learn in your failures as well as your successes, and so somebody needs to try it. This research takes a lot of ideas, cumulative needs of people, the industry across the country, and says, let's look at trying it. So it's information that's gleaned, that's a priority information, and then the implementation can go that much further to benefit a lot of people.
There's always some risk of being first, being on the leading edge and trying something. And you know, there's a learning curve in there that you have to kind of shake it out a little bit as you go through trying a new technology or a new process. So whoever goes first takes on a little bit more risk in doing that. We think when that leader is working side by side with the Federal Highway Administration, you know, we can bring some extra technical expertise to that state that they might not have. It makes it easier maybe for that leading state to take that first step and say, we'll be first, we'll try it. And that's a really critical part of something like SHRP 2, is having a state or a few states that are willing to say, we'll go first.
Simply put, the recent trend toward reducing investment in the nation's highways and roads will lead to increased congestion, traffic delays, and further deterioration, creating more volatility in supply chains, raising the cost of goods, and reducing the safety of the traveling public.
Oftentimes, to accelerate construction of a bridge, you do have to simply pay more money. But the citizens, the users of the highway, are paying more money for each minute or each hour that they are delayed in their trip. They're consuming gasoline and diesel fuel. The opportunity cost for the time lost is money lost to them.
The unique thing about this bridge, as I said, the construction duration is only 2 weeks from the time that they close the road to traffic until they have a completely new bridge in place and the road reopened. If this bridge was constructed kind of the conventional way, the way we've always done bridges, it would take 4 to 6 months.
A conventional method will not be acceptable by the traveling public. And that's a very quick thing that you're going to find as you go out. You have your public meetings on projects. If you were to go somewhere and say, I have to close down this road for 9 months or 6 months to replace it, they're going to want to know, can you do it quicker, or are there different ways that you can do it? So the business case for most of these things, I believe, would be we're going to minimize the impact to the constituents, to the traveling public, and although there'll be some short-term pain, there'll be a lot long-term gain in that area.
When you bring forward new approaches, new technologies, you can reduce congestion out on the system. I think that helps from an economic standpoint. It helps on a quality of life from a personal standpoint, from an individual traveler who's trying to get home that day to get to their kid's soccer game. It also helps the business that's trying to move their goods from one part of the country to another.
States all over the country are interested in this process. Everyone has traffic problems. Everyone has bridges that need to be replaced, and they can't stop traffic to do that. So we've got some ways now that people can take these tools home, take some of the standard details and things that we've developed as part of the project, and take it home and apply it to their own situation.
We can't afford to let our roadways be incapacitated because of construction projects. And so the faster we can go, it's clearly valuable. When it really matters, we put very big incentive and disincentive clauses into our construction contracts, and there's no question when we do that we're likely to pay more money, but it is clear that it is worth paying that money to get the contract finished and wrapped up and get the contractor off the roadway sooner.
We need significant changes and a plan of action that includes the use of emerging technologies and innovative strategies. Accelerated bridge construction can be a key element in this plan. DOTs and other owners can confidently take the lead and establish ABC, not as an interesting research project, but as an everyday thing.
The 23 years I've worked with the DOT, it's been interesting. We all look at projects like this, or really even standard projects, as these are our projects. Everybody has ownership for that, and it's always like that. The people that live in this area that use this bridge, it's their bridge. And so I think it's very satisfying. Everybody that has worked on this project, from all the agencies, from all the levels within the DOT, do consider this project their project, our project, and very good decisions have been made on this project, and it is a successful project, and it's just a testimony, I think, to the way that we want to work together and the way that we want to serve the public.